Assalamualaikum warahmatullahi wabarakatuh and a very good day to everyone. My name is Tuan Siti Nurul Syafiqah Tuan Lenik from UiTM JK Pahang. I will presenting my final year project entitled Assessment of the Selected Heavy Metals Contamination in Paddy Farming Soil in Kelantan under supervision Dr. Muhammad Zahari bin Abdullah alias Rafai. This is content outline for my presentation. Firstly, introduction. Background of study. What is environmental pollution? Environmental pollution can be defined as the contamination of the biological and physical substance of the earth system that release into the environment and it give impact to the nature of the environment. The pollutants originate from the many sources including agriculture development, demographic growth, and urbanization can give harm to the environment. Water pollution, air pollution and soil pollution are the main type of environmental pollution. So, based on this study, I am more focused on the soil pollution at the paddy farming soil. What's the causes of the contamination of the paddy farming soil? The examples of the heavy metals that can be found in the soil were included lead, zinc, copper, mercury, iron, nickel, manganese, and arsenic. The excessive uses of the pesticide and fertilizer which lead to the heavy metal pollution is one of the factors that polluted the soil. Farming soil area have been destroyed by the urbanization that made the soil fertility become worse and less fertile. Next, go to the problem statement. Problem statements of this study is about chemical fertilizer and pesticide have been increasingly used in agriculture activities. They were used to manage pests and to increase agriculture production, but some farmers have used them in an excessive amounts, which can lead to the degradation of the ecological components, including soil fertility. Heavy metal and pesticide are among the most dangerous environmental toxins. This is due to the fact that heavy metals found in the fertilizer and pesticides such as cadmium, lead, copper, zinc, as well as pesticide. Furthermore, heavy metals found in chemical fertilizer and pesticide can harm plants and soil. The objective of this study are, firstly, to measure the concentration of cadmium, chromium, copper, iron, manganese, lead, zinc, nickel, and magnesium in the paddy farming soil. Secondly, to assess the pollution levels based on the contamination factor, enrichment factor, and geoaccumulation index of the study area. Moving to the literature review, which consists of two parts, which is paddy soil and ecological risk assessment. Firstly, paddy soil. The word paddy is derived from the Malay word which is padi. Padi means rice plant. Paddy soil is also known as a soil that is submerged during rice cultivation. The quality of the paddy plant become worse because of the excessive use of fertilizer, pesticide, and other agriculture chemicals. In addition, metalloids such as arsenic, mercury, selenium, lead, and cadmium are among the common metals present in rice-growing soil. So, the concentration of the paddy soil can be contaminated by the heavy metals. Ecological risk assessment. Ecological risk assessment can be used to analyze any possible harm to ecosystem caused by the human activities. Pollution index are very important to determine processing and analyzing the raw environmental information to public and the decision maker. The examples of the indicators that have been used in this study are contamination factor, enrichment factor, geoaccumulation index, which is to measure the level of heavy metal pollution in environment. For methodology, the paddy farming soil in the three area at the Pasir Putih, Kelantan, which are Kampung Bukit Tanah, Kampung Genjerin, and Kampung Danan, was selected as sampling site. The paddy soil was collected during harvest season and collected manually using a plastic tools from deep ranging from 0 to 30 cm. Then the soil samples were dried and then put in the oven at 40 degrees Celsius for overnight before being homogeneous truly. The homogeneous sample were grounded into a small particles using pestle and mortar, then sieved for analysis. For each subsample soil, the sample was digested using the web digestion method that used hydrochloric acid and nitric acid. Then, the subsample was digested in the beaker using the hot plate at temperature of 200 degrees Celsius. When all the sample was dissolved, the sample was filtered into 100 ml volumetric flask, then ionized water was added until calibrate marked. The sample then kept in the refrigerator before analyzed with ISP-OES instrument. So overall, 30 sample was collected and analyzed by ISP-OES. Next, for result and discussion. This figure shows the concentration of selected heavy metal in the sampling site. The heavy metal that found are CD, Cr, Cu, Fe, Mn, Pb, Zn, Ni, and Mg. The blue bar represent for the geochemical background value. Red bar represent for Kampung Bukit Tanah. Grey one represent for Kampung Genjering. And lastly, yellow bar for Kampung Danan. The average concentration of the chosen metal in the paddy soil was lower than geochemical background value. The concentration of heavy metals measured in Kampung Bukit Tanah is higher compared to Kampung Genjering and Kampung Danan. The concentration of heavy metals in this study area was found to be unevenly distributed among the three sampling areas. The element with the highest concentration of the toxic element that have been detected in these three different study areas is iron, Fe. The selected study area were away from the industrial and urbanization activities and may not have contributed to the increase in metal concentration in the area. Pesticide and fertilizer are all the possible contributor to the presence of heavy metal in the soil samples. Contamination factor. Contamination factor is an index that is used to define the metal concentration of environmental sample. It is used to calculate contamination or pollution range of some metal. In this study, the contamination factor value for the study metal varying from 0.02 to 5.3. The highest CF value was recorded for cadmium in the Kampung Danan sampling location, which is 5.3 contamination factor reading, which was classified as moderately contaminated. CD was also found slightly contaminated in Kampung Bukit Tanah with a CF value of 3.0 and not contaminated in Kampung Genjering. Nickel, zinc, manganese, and magnesium were observed with CF value below than 1, which indicate an unpolluted level in all three paddy farming locations. The order of increasing CF in three different paddy farming soil area was magnesium, nickel, manganese, ferro iron, zinc, chromium, copper, lead, and cadmium. Enrichment factor. Enrichment factor are used to measure the amount of metal added to the soil. Based on the data obtained, the enrichment factor were measured in a range of 0.13 to 30.5. For calculating enrichment factor, Fe was used as concentration reference metal in the study area. CD was recorded the highest enrichment factors in compound diamond, which indicate very high enrichment level. Magnesium had the lowest enrichment factor of any Paddy Farming Soil location, which indicate minimal enrichment. Geoaccumulation Index. Geoaccumulation Index (IGU) is the indicates that used to define and determine metal contamination in the soils. Based on this study, IGU values at all three paddy farming locations are negative, indicating that they are free of that particular metal. There are only two metals that show positive value for IGU, which are Cu and Pb. Both metals were recorded as moderately polluted. Meanwhile, the other metals which IGU value below 0 are considered unpolluted in those particular study location. Based on the IGU value obtained in all sampling locations, it could be concluded that the soil of the paddy farms are not seriously polluted by the studied metals. This is formula for calculating contamination factor, enrichment factor, and geoaccumulation index. Conclusion. In conclusion, the study was done to evaluate the distribution and pollution status of 9 metals in 3 paddy fields in Kelantan. The data obtained clearly shows that the concentrations of the studied metals were unevenly distributed at all sampling sites. In general, Fe, which is iron, was found to have the highest concentration compared to the other metals, and CD, cadmium, has the lowest. The result of CF, AF, and IGU clearly indicates that the selected study area were not seriously contaminated by the studied metal except for Pb, CD, and Cu, which show slightly higher levels of contamination.